I'm an engineering manager at sysdig, and I'm a core developer of the open source system troubleshooting tool sysdig. What are we going to talk about today? Today is going to be all about monitoring and troubleshooting containers. And I'm going to spend the first part of the presentation talking about best practices and tools in the ecosystem for essentially achieving this goal and seeing what's inside your containers. Then we are going to go a little bit more advanced, and I'm going to use a Kubernetes cluster to show you how to do real troubleshooting use cases with containers. I'm just picking Kubernetes because nowadays no one starts their containers from scratch anymore, right? You need a cluster manager, and Kubernetes is a completely legit example of such a tool. And then we're going to talk about how you bring these monitor and troubleshooting concepts to scale, so to monitor hundreds or thousands of nodes and containers. So the demo environment that I have here for the rest of the presentation is essentially a Kubernetes cluster that is running locally on my laptop, and it's only one namespace. Namespace is this metadata bit that Kubernetes uses to group together containers. And inside this namespace, essentially, I have tons of containers running. I have a web tier of containers running WordPress, Tomcat, a bunch of databases, MySQL, Cassandra, Redis, all of it. And each of these components that lives in separate containers is automatically managed by this concept of controllers. So if you have done work in the cloud on AWS or something like that, it's just exactly the same as, say, an auto-scaling group. So while an auto-scaling group keeps up and running a specific set of virtual machines, a controller in Kubernetes keeps up and running a specific set of containers. And so we have all this thing, and how does it look like? If I go here, I have it up and running. So if I do PS on my machine, I can see that I have tons of processes, a bunch of Apache, Java, all sorts of things. There should also be Mongo and MySQL. Oh yeah, here we go. Look at how many. And if I do docker ps, which is the command to see which containers are running, I can see that I have a few dozens of containers with all these weird names: Java app, WordPress, client, MySQL, all sorts of that. So these are essentially a bunch of containers, way more than what I would like to handle. And while people literally peeing their pants by how excited they get by such a marvelous cluster orchestration architecture, the only thing that I can think of is this. This is essentially going to be a big troubleshooting nightmare, because if something goes wrong, and it will inevitably go wrong at some point, there's no question about that, now you not only have a bunch of applications that you need to troubleshoot, but these applications are mostly hidden inside containers. So they are separated from the immediate facing part of the OS, and they are communicating with each other using all sorts of level of virtual networking that makes it even harder to troubleshoot. So in cases like these, essentially, what do you do when you want to do some monitoring? So there are some tools, for example, in the containers and in the Kubernetes ecosystem. For example, you can use the Kubernetes UI, or you can use a tool that is pretty popular with containers is cAdvisor, which is essentially a little component that will fetch basic system metrics such as CPU, metric, disk I/O for all your containers, and will export them in a REST API that you can then consume through other higher level visualization tools such as Grafana. But if you are anything like me, you'll find yourself most of the time wanting more. So you'll essentially find yourself wanting deeper, much deeper information, such as what files is my container touching, or what kind of network activity is the database that is inside a container doing. And tools like the ones that I just mentioned are not going to be helpful. I mean, you can just get a clue that there might be something wrong, right? And if you want to be really effective and answer this question, you really need to do what I call troubleshooting like a pro. This is a great map done by Brendan Gregg that summarizes essentially the state of the art of troubleshooting. So when you want an answer to a hard question, you need to pick the resources that you're interested in monitoring, and you need to apply the good old system troubleshooting tools that we have had around for decades, and those will likely contain the answer. Although, when it comes to containers, these tools are a little bit less effective, and let me show you what I mean by that. So, say that I just want to do a basic monitoring on the CPU of my processes. So that will be the yellow box in the middle called scheduler. And of course, it goes without saying that the first tool that comes to mind if you want to monitor the CPU activity from the scheduler, you stop, right? And so we're going to switch my shell, and we're going to call top. And so here I see all sorts of processes that are executing, and I can see that towards the top I have Apache, I have MySQL, and all this is good. I mean, it's all very good information. But all these Apache processes are living in separate containers. Top is not giving me any information about in which container this specific Apache that might be consuming 100% of the CPU is living. So I have to dig that information myself. And so top, for example, is not extremely effective if you run it in the host and not inside the containers. If you run it inside the containers, it's going to show the CPU of the processes of the container. But that's going to be, one, a nightmare, because if you have 50 containers like I do, you cannot run 50 instances of top. And two, the image that the containers run, so the containers root file system, I call it the way, it should be a stripped down version of a Linux distribution. It shouldn't have all the tool bells that you might need, because otherwise it becomes a virtual machine, and you might just as well just use a virtual machine. And this is one example. Another pretty typical example is the network, right? So the network is the green box in the center. So the typical tool that I use to just take a look at the network connection is netstat, right? So I can go over here, and I can do netstat, and this will show me a bunch of connections, which are fine, but say that I'm interested in knowing what sort of connections are being done to MySQL that is living inside a container, right? Netstat, grab 3306, port of MySQL, and there is nothing. Even though I can bet $100 that there is traffic going to my MySQL container right now. Why is this? This is because each container gets its own network namespace. So each container gets its own network stack with this private set of network connections, interfaces, and all that. And when I run a netstat in my host, it's going to get the information from the global namespace, which is completely different than the namespace, than the network namespace where my containers are living. So an alternative again here would be to run netstat inside the container so that I could run it against the network namespace of the MySQL process. But then again, this could just happen if I could install netstat inside the container, which is again is not a recommended practice for containers. I mean, ideally containers should have one single binary, which is your executable that you need to run, and maybe the set of shared objects that your program needs, like libc or SSL, whatever. And so, at sysdig, essentially, we felt like the ecosystem for troubleshooting could be improved when it comes to container. And so I want to spend the rest of this part of the presentation, talking about this little guy in the top right corner, sysdig. And so, sysdig is an open source system troubleshooting tool, relatively new, that it wants to be like a TCP dump, not for your network, but for your entire system. So sysdig doesn't work with network packets, but works with system events. And it allows you to filter them and run useful scripts on them. It's completely open source. It has native support for containers. a command line interface, a cursor UI, and before showing you how it works, let me quickly talk about essentially the core architecture of it so you can understand what I'm going to show next. This is the typical architecture of one host where you have a single running instance of the kernel, and then on top of the kernel you have a bunch of processes. And some of these processes are running outside the containers, like in the left, or some other processes are running inside containers, such as these 3 big boxes on the right. And the containers can be, LXC, Docker, whatever container runtime you want. But at the end of the day, the processes will always talk to the outside world or among themselves through the kernel via the system call API. So to the kernel, it doesn't really matter if a process is in a container or not. They're just the processes, and processes all talk with the system calls, which is essentially the API around which a process does anything useful outside the scope. And so sysdig works by having a little kernel module that will instrument all the system calls that are happening in the system and will essentially deliver them to the sysdig user space application that can live either natively in the host or in a separate container. So with this pattern, which turned out to be very, very powerful, as we'll see in a second, a few more examples, sysdig can see inside your containers from outside the containers, which has an incredible advantage if you need to do essentially troubleshooting in production where you cannot mess too much with your containers. So how does sysdig work? In its typical invocation, as I said, sysdig essentially is nothing more than a system calls differ. So this is not very user-friendly as an output. But the first thing that I can do is I can limit the scope of events that get printed on screen by applying filters. If I do -L, I get access to all the dozens of filters that I can use to filter this verbose list of events. And the nice thing about the filters is that they are stateful. So instead of talking about file descriptor, which is, a file in the language of the system call, I can talk about file descriptor or directory, file descriptor or file name. And sysdig has an internal state machine that will be smart enough to translate those concepts in concepts that can be applied to the system calls. And they can filter all containers and everything. So if I now use sysdig and I use as a filter container.name contains MySQL, this will show me a much more limited output that will just show me essentially the events, the system calls done by MySQL in a container with this ID and this name. And I get other information. For example, I get the process ID as seen outside the container as seen inside the container. And with filters, you can essentially play with them to get to a very higher and deeper level of visibility. I know what you're thinking, that when I say this is less verbose, you're really thinking, yeah, this is really not less verbose. It's still very confusing. But by the time we finish this talk, you will love this list. That I can promise. So if this list is really too much, another thing that you can do is you can chisel this list. So we have this concept of chisel that are little Lua scripts that sysdig supports that can ingest this high volume set of data and spit out something that is more user-friendly. These are simple Lua scripts. So if I do, for example, sysdig-c, I get access to all the dozens of chisels that we support by default. So let me run, for example, top file bytes. And notice how now I'm not getting the list of events, but now I'm getting a much more useful output that will contain the I/O bytes done in my system, sorted by individual container name and file name. This is an incredibly difficult metric to get in Linux. Even if you're familiar with the advanced stuff, how do you break down the I/O at the file level? Of course, you can do, you can write your thing with probably system tap, or you can do probably something with eBPF, but getting something as user-friendly as this and as immediate, we think is quite an achievement for sysdig that moves on essentially the whole troubleshooting ecosystem. And this is essentially sysdig in its command line interface. Then we have sysdig. Sysdig is the curses-based interface to sysdig, which will remind you a little bit of htop, where you can see a bunch of processes essentially with the system resources that they are consuming, all updated in real time, of course. But notice how now we have this column called container, which I can sort by. And now this will correctly categorize me my processes based on the container name. So finally, if I see a process that is misbehaving, I can literally say, okay, I have to go to this container, and I don't have to enter in a trial and error approach where I need to probe all my containers. And this is a huge advantage, but essentially the similarities between top and htop and here. Because if I press F2, I enter the views panel, and this will show me that here I was just using essentially the processes view. So I was looking at my system under the point of view of processes, but I can do much more. So for example, say that I'm interested in containers. If I do containers, now I get into a view where I'm seeing the containers with their long names chosen by Kubernetes, the container ID and their image. You can see that these are the images that we used. And the resources that they are consuming. So this is also very useful. Docker provides something that is similar, but this is generic, works with every container that you might have, because this is based on C group, for who is more savvy about the tech behind containers. And I can filter them. So say that I'm interested in the Redis container. I can see that I have this one. And we have this nice concept of drill down. So if I press enter, I drill down into the container, and now I'm brought to a view, as I can see up here, where I can see the processes. And I can see that I have essentially the Redis server process here. And I might not be interested in this view where I just see the processes, but let me get a view of the network connections inside this container. And now I'm getting them. I can see the individual network connections that this container is doing with the port and all that you would expect, the container and the process. So this is something that before with netstat wasn't possible unless I ran netstat inside the container. Whereas with this, I can get it in a pretty elegant way that works across containers. And it doesn't end here. Say, who tells me that I have to stop to this container list? Since sysdig is getting the information from the system calls, I can look into what's happening into this connection. So if I press F5, I enter into the echo mode, where now I'm seeing the I/O buffers that are being exchanged on this connection. So this is like a TCP dump that works across containers, and instead of selecting the port, which used to be just the only key that you had between your application and the network, now you can directly filter on the process, because we did it at the system call level. And so here I can see, if you're familiar with it, if you've ever done some Redis programming, you can see that this is the typical Redis protocol where I have, for example, I see that the Redis process read from this connection, and this container read this payload, which is get counter variable, and then I can see something, okay. And then I can see that always the same process replied on the same connection with the response. So this is the typical Redis protocol. And this is very useful if you're in production, because you can inspect what's happening in a very user-friendly way. And it doesn't have to stop here. You can even go more advanced. So say that I want to correlate this information with the actual activity that the process is doing, not only from the network point of view. So I can go back to the processes, and I can go back to the dig mode, F6. In this mode, I will see the flat list of system events applied to Redis. And this can be a little bit intimidating, but we can find some pretty cool thing about it. For example, let's go, let me get a transaction which might make sense. Let me get an increment. Yes. So here I have, in this event, this Redis container by this long name, and the Redis process. Unfortunately, the resolution is a bit low, but on your laptop it will fit on the screen. It read from this connection a payload, which was again here, a payload get counter. And immediately after, we can see that the Redis process didn't really do anything He just did a bunch of epoll for asynchronous waiting, and then immediately wrote, by writing on the same connection, the response, which is essentially the value of the counter. But when it gets interesting is, let's compare this read transaction to a write transaction. So in this subsequent event, I have Redis that read an increment request. So this is a write as opposed to before. Before it was a read, now it's a write. Increment this counter. And let's see how Redis handled it. We can see that here, instead of immediately serving the request, Redis is writing it to /data/append only.aof. What is writing to /data/append only.aof? Is writing an exact copy of the transaction. So notice how we switched from the network domain to network and file domain, and we correlated everything. Why did he do this instead of just returning the response right away? Well, because Redis is an in-memory database, but it needs to essentially to cover its ass in case there's a power outage or a process crash, right? So it needs to write all the write transaction, all the transactions that affect the state of the database in a commit log, so that in case something goes wrong, the process will be restarted and will reconstruct the state from disk. And you will make sure to do so before acknowledging the client, the response. In fact, we can see that immediately after it writes to the connection, it will write the updated counter, which is 2089, as opposed to before, which was 2088, because it incremented. And so, overall, this is pretty cool, and we went very deep. But you can do really a lot of things. For example, another thing that our users like a lot is this spectrogram, where you can essentially take an X-ray of your process, and you can essentially chart the system events organized in buckets according to their latencies. So here you can see that there seems to be a fair constant amount of activity exactly around 100 milliseconds. There is no system event that will return exactly 100 milliseconds. So this must be some sort of timeout system call, some polling that happens exactly 100 milliseconds. So again, this might be useful depending on what you're looking to troubleshoot. I'm just trying to show you that there's a lot that you can, inquire about when you are doing troubleshooting. And other things that are useful is, for example, if I go to the, let me go back here. If I go to the containers, I need to get my filter. If I go to the containers, I see that the container names are quite huge and quite ugly. This is because these container names are chosen automatically by Kubernetes. But if I am an application developer of a system administrator, I don't really care about these names because I didn't choose them. I care about the abstractions that I choose, which in this case is the metadata that I gave to the controllers. The controllers are the Kubernetes entities that create the containers for me. And so in sysdig, we also have integrations with cluster orchestration. No. It's coming. All right. Yes. So with sysdig, essentially, we have integration with cluster orchestrators, such as Kubernetes, Mesos. And so I can go into Kubernetes controllers view. And this will now show me the controllers that are happening in my system with the resources they're consuming. And notice how the names are very user-friendly with labels that I manually put inside the configuration. This is the language that I like speaking because these are the information that I directly chose. And I can select one, for example, the WordPress, and I can drill down into it, and this will bring me down to the pods, which are thin wrappers around containers that Kubernetes put, and I can zoom in into a pod, and now I can get to the individual container that corresponds to this controller. And once again, while I'm here, I can see all sorts of things. So I could see, for example, the files that are being opened, read, or written the most for this container. And I can see, and not surprisingly, it's a CSS file that is being intermittently read. So this is also good for doing this sort of things for I/O. And generally, there's tons of things that one can use. I'm just going to show you one that I particularly like. For example, the spy users. With these spy users, this will essentially track all the new processes execution by measuring the fork and the execv system calls that are happening in the system. So, for example, here I can see that I have a bunch of curl commands that are keeping my WordPress infrastructure and my Java app containers up and running, to get some CPU usage so that we could see something with sysdig. And the nice thing about this is that this is not as trivial as it seems, because this is a continuous evolution of your system. If you run, for example, if you're in top and you run a process that takes less than 1 second to execute, you have a very good chance that this process will never show up. If you run a little script that will keep executing a little program every 500 milliseconds, you have a good chance that top will not show it. You will see it in the global CPU usage, but you will not see it in top. With sysdig instead, since this is system call driven, you will see it, even if it was just active for 1 second. So again, this is another thing that I like describing. This completes essentially the first part. And now in the second part, I want to go a little bit more advanced and doing some live troubleshooting. So I'm going to start by getting rid of all my containers of all this test infrastructure and creating a new one from scratch, a much simpler one. So I'm going to just tell to Kubernetes, delete rc pod service all, and I need to put space there. So what this does, this will essentially delete all the containers that I created. And I will want to create a little microservice based on containers where I want to create 2 simple Nginx containers serving static HTML files, and then I want to create a load balancer on top of them so that the traffic is equally routed between them. This is a simple, so let me check that my containers, okay, they are going away. So this is a simple in Kubernetes I'll do, and again, I'm not running my containers directly, I'm using Kubernetes. So I'm going to tell Kubernetes, run me a new thing called my Nginx with an image, Nginx from the Docker Hub, the official Docker image. Create me 2 replicas and put them on port 80. So while I do this, Kubernetes will create for me 2 containers. In fact, if I go here in Docker PS, I can already see Nginx 1 and Nginx 2. Now I need a load balancer, right? So for the load balancer, Kubernetes provides this nice abstraction called service. So if I create a service, Kubernetes will automatically create me an abstract load balancer that will have a virtual IP address, and every time I connect to that virtual IP address, the traffic will reach one of those 2 backend containers. This is as easy as doing kube control. Expose rc my Nginx. I'm going to put it as on port 8080, and I'm going to put it as a target port 80. Perfect. So now if I do kube control get services, this will show me that my service, my Nginx, here, is listening on this IP address. So whenever I do curl 10.0.0.217 on port 8080, I get a response from my containers, and this is routed from one Nginx container or the other, depending on my luck. And so I want to see how this works I want to study how this works from the system events point of view, because that can be useful during troubleshooting. So I'm going to run another shell where I'm running sysdig in background while I do this curl command. And the syntax I'm going to use is just sysdig. Okay. These are just normal flags to make just the output a little bit more easy, but they're nothing interesting. And I'm going to say to sysdig, show me all the network activity as a filter, because that's the only thing that I'm interested in, and exclude me the traffic on port SSH, because there will be too much noise, because this is my VM I'm connecting to the SSH. So if I do this, I start seeing a bunch of crap essentially, and if I do curl worked, and so now in the sysdig trace, I can see how essentially this transaction was served, and it's quite an interesting learning experience. So let me start by looking for curl, and I can see here the curl in my host, because I didn't run it inside any container, immediately connected to this host, 10.0.217 port 8080, my service virtual IP address, and immediately sent on that connection this HTTP request. This is a typical HTTP request, get slash, user agent curl, couldn't be any simpler. And immediately after, I can see that this process, Hypercube, is reading the same HTTP request. But notice how the process is reading it from a whole different connection. This connection has an endpoint, another IP address, and a completely different port. So Kubernetes creates an IP tables rule in my host that says, every time you connect to 10.0.217 on port 8080, hijack this connection towards this IP address, which is the physical IP address of my node, and this port, where the Hypercube process will listen. Hypercube is essentially this Kubernetes user space proxy process that does exactly this, implement services. And after reading my request, Kubernetes, you will see that will send, where is it? It's here. Kubernetes will essentially connect to one of my nginx containers, particular, this one? How is it? Yes, it's this one. Yeah, right here. 172.17.02, which is one IP address of my container, and will forward the request, which is then immediately read by nginx, which will receive it. Notice we will receive the same payload in this container. So all this is just a loop that will close, and the data will be sent back the same way it came through. And this is how services are implemented. And this was, a case where everything worked. But let me redo it. Oops. Let me redelete it and start from the third time. And let me run it. And let me expose it. Right? So now I already did it. I did a little mistake. So this is my new IP address. And if I do 8080, I get connection reset by tier. Even if my containers are running. You can see that I have 4. So everything is actually running. So what happened in this case? Now I could actually start and go probing my components to see, okay, can I ping these containers and stuff? But in production, this might not always be viable. So that's why I want to show you this passive approach once again. So if I run the same command and I run curl, now I have a trace file that will show me what happened, and I can analyze it. So if I do curl, So if I do curl, I can see that at the beginning, curl essentially connected to 10.0.58, so the connection that curl did was fine, port 8080, and send the HTTP request. What happens though is that here, just by visual inspection, I don't see anyone else reading anymore these HTTP requests. There should be Hypercube reading it. What Hypercube instead seems to be doing seems to be connecting to these two IP addresses, 17.03 and 17.02, and then it seems to immediately close the connection without, effectively establishing a connection with my nginx containers. Why is that? Again, the answer is here. Maybe some of you already noticed. But this was the trick. Port 8080. My nginx containers, if you remember, were listening on port 80. On port 8080, there's nothing. So this is why I get a connection reset by tier. And why did this happen? This happened because I intentionally made a mistake. This was my first invocation, and this was my second invocation. Notice how I omitted target port 80. So Kubernetes assumed, okay, you didn't specify any target port, so I'm just going to assume that the containers are listening on port 8080, which is the same port you specified as a listening port for the service. Now, I don't know about you, but this was a simple example of when I do these sorts of things, like for work, I enter in these situations all the time. Like, you always do these little typos and mistakes that maybe take 3 hours to figure out. So I hope that I just gave you a workflow or something that might not always be more effective than your normal troubleshooting tool, but can definitely be considered as a viable alternative if you think it's worth. And this was essentially the second part of the presentation. For the third part, just wanted to talk to you a little bit about what happens when you're in multi-node, because until you're playing at home or in a very confined environment, you can get a long way just with a tool like sysdig or any other tool in the ecosystem. But when you start managing a Kubernetes cluster of 1,000 nodes or something, then the SSH approach is not really be scalable. I mean, mind you, it will still be very useful. Once you know the problem, you need to dig deeply into it with a tool as advanced as sysdig or any other tool that you might prefer. But for quickly spotting on the health of your application, it's not going to be useful. And so at sysdig, we thought about this and we said, is there a way we can leverage the sysdig technology to build something that works on a multi-node? And the answer to this was essentially yes, and it is sysdig Cloud. So sysdig Cloud works by essentially having a version of sysdig that reports to one centralized backend that you can self-host, or there's also a SaaS version that we provide, and we'll show you every component of your infrastructure over here. And here, for example, I have the same application that I had on my laptop, but scattered across 4 nodes, 1 master and 3 nodes. And I can see that I can see essentially all the containers with all now the resolution again is a bit low, but you can get the idea. Where I can see essentially a bunch of stuff. I can see CPU, memory for all my containers, and this is pretty advanced information because I can, for example, click on a WordPress container, and I can go then to a view for HTTP, and I can see the individual. This is unfortunate. Let's see if I can. Well, I cannot augment the resolution, but here you should see essentially the individual URL. Yeah, you can see that if I do a tooltip, they show up. And these are the URL with their frequency as they're happening in my infrastructure. And this is all information that is gathered automatically by dissecting the system call information. The exact same way like you would do for Wireshark. Most of the team at sysdig had worked in our previous company at Wireshark that probably most of you know. So we definitely leveraged that bit, which was quite effective. And another thing that you can do, which is quite interesting, is that if you really don't care about your host anymore because you care more about your containers, you can just get rid of your host from the hierarchy and just see all your containers, how they're performing. And you can sort them by CPU, and you can even slice and dice them by Kubernetes entities. For example, first we were talking about the Kubernetes namespace and controllers. So something that I can do, where is it? Here. I can essentially group them by namespace and pods. So now I can see which WordPress is in which namespace, because I could have a dev namespace and a production namespace. And of course, I would expect different performance between one or the other. And then I can click on the whole namespace and see essentially all sorts of things. In fact, let me go to this, let me reset the view, and let me show you something that our users like a lot, which is the topology map. So, what happens if I take all that boring list of system calls events that we were seeing before, and I chart them on a map? I get this. I get an organic view of your infrastructure, which is automatically created, and I can take one node, I can zoom in, and I can see the individual nodes, and not only the individual nodes, I can see the individual containers and the individual processes. And this is done all using that boring list of system calls we were seeing before. There's nothing else. There's a little bit more of metadata that we are fetching from Docker and Kubernetes, but those lines are gathered by reading those read and write system calls. And don't take a visualization like this for granted, because if you don't instrument things like in a container-oriented way, and if we go back, for example, to, let's see, if we go back to the original grouping, which was essentially my master and my slave, and I decide to take a look at the same topology, notice how now this is extremely complicated. Like, it's a fully meshed network of containers, and this is what I was talking about in my third slide, a troubleshooting nightmare. And so, with all this work that we have been done by essentially slicing and dicing your data by containers and applying right metadata to it, we try to make some clarity out of it, and this expresses itself in both sysdig and sysdig cloud. And I think I don't have anything else. So if there are any questions, I'll be happy. Yes?
First, I think the saying is, shut up and take my money. How does this get installed on a Kubernetes provider like gcloud, where they're setting up the hosts?
Yeah, exactly. So, are you talking about sysdig or sysdig cloud?
Sysdig cloud, sysdig.
Okay, so
how does the kernel module get in?
Okay, so for the kernel module, we have done a lot of work. So essentially, if you talk for Google Cloud, and more specifically GKE, the managed Kubernetes, you still have access to your underlying nodes. So you can essentially tell Kubernetes, deploy me this container, which is the sysdig cloud agent container, and you're going to run this container with a special flag, which is -privilege, which will essentially say this is a root container. So that container will have access to the insmod system call, and you'll be able to load the kernel module. There's really no manual steps required. We took a lot of work in making sure that everything is nice and simple and automated, so it's almost always a one-liner. Also managed platforms such as Amazon ECS or Google GKE. So, yeah.
Getting this amount of information seems very useful. How much overhead does sysdig introduce by monitoring? Who watches the watchers?
Yeah. So there are 2 points when it comes to sysdig, depending on the architecture. One is the overhead caused by the driver, and one is the overhead caused by the user space application. When it comes to the kernel module, we put a lot of effort into making sure this was as really zero overhead as possible, as much less overhead as possible. And in fact, if you go on GitHub and you look at our code, the kernel driver is extremely small. Like, I think it's probably 2,000 lines of C code or something like that. Maybe a bit more because there's some boilerplate. But and so we worked a lot into exporting everything to user space by memory mapping buffer, so we do zero copy stuff. And so the kernel part is very low overhead. The user space part depends on what you do. If you with sysdig, you're going to run a chisel that wants to compute 50,000 prime numbers for every read system call that you see, then it's going to take 100% of the CPU. Or if you're going to choose to dump these events on disk, enabling compression with zlib, it's going to take 100% of the CPU. The sysdig cloud agent instead is this version of sysdig, and that has been extremely optimized for being lightweight. So the sysdig cloud agent reads all the events, discards them as soon as possible, and creates this very little and lightweight state that is then periodically sent every second to our sysdig cloud backend. So when you translate it in real terms, the overhead is very minimal. I would say always less than 5% of CPU or something like that. But since we are at an engineering conference, if you really want to break it, you can. Because if you go to an atypical workload where you just do, I'm just going to do a bunch of bogus system calls. So if you're just going to write a C program that does while true open -1, which is a file descriptor that doesn't exist, you're going to do 10 million system calls per second, and that is gonna reflect also on the agent. So and for those cases, we have an automatic watchdog that when the agent sees it is consuming too much, it starts discarding events according to some politics. But in a normal case, events are not discarded and performance are extremely contained. And you can check it out, and if you experience otherwise, we'll be happy to hear.
Report a bug.
Yeah, report a bug. There were other questions. There are still. Yeah, there's one down there.
I noticed you have the Mesos integration. Do you know what version that came in on? What version of sysdig
The sysdig integration with Mesos came up a couple weeks ago in 0.9.0. Yeah.
So just a couple questions about like data retention. So
Yeah.
So as I understand it, just the sysdig by itself is not retaining system call events except while you're watching, and then it's got some sort of buffer. Or
No.
okay,
Look at this. I can do sysdig trace.scap. This is not outputting anything on this. It created me a trace file, which is 500 kilobytes, and I can read it. And it contains all the events that happen in that system. I can also apply it at Chisel. I can see all the files. So you can automate this in cron or with alerts, but yeah.
Okay, so but for example, while you're in the curses UI, is it going to, like, if you leave the curses UI open for a long time?
It's just going to be real time.
Okay, yeah. So, and then the other question would be, in Sysdig Cloud, you say it's streaming events to the cloud. Is it streaming the raw events to where this could be viewed and like troubleshooting? If I saw a problem happen in the last 5 minutes, could I go on Sysdig Cloud and see like a capture of the system calls raw from 5 minutes ago before I knew I had to monitor something?
So the answer is no. There is an integration with sysdig, so you can create a sysdig capture from Sysdig Cloud, but it will be from that moment on. So we don't keep a buffer, mainly because it's prohibitive. Like if you measure the throughput, those are hundreds of megabytes per second of shit. Really, there's really a lot of stuff. Like if you had to dump everything, like on a busy thing, it would be insane. So we haven't found a good solution. We thought about maybe keeping a subsampling of data. Like, okay, maybe let's keep just the I/O activity and let's cap the I/O buffers to 50 bytes per event, so we can keep things reasonable. But that hasn't happened yet, mainly because we haven't had time to experiment. But it's definitely a good. I mean, I would love something. Keep a rolling capture of the last 10 minutes. So if something goes wrong, just create a snapshot and dump it on this. Would be extreme.
Application specific too, so it's hard for you guys to know what kind of filter I would want on that to be something configurable.
Yeah. But that being said, if you are willing to essentially waste a little bit of resources, Sysdig supports dumping to files with several truncation policies. So you can create a file and always say, split these files every 100 megabytes or every 10 minutes and keep a maximum rotation buffer of 10. And so, of course, there's going to be resource hungry, CPU and I/O especially, because, I mean, every system call is going to be dumped on disk. So, but if you want to achieve, there was a pretty cool blog post that I wrote a while ago. It's called Phishing for Hackers. And I just did that. I exposed a Linux server with the root password to password or something like that. I let someone hack into the SSH while Sysdig was running in the background and keeping capturing, and then I explored, and it was pretty cool. Like, if you are interested in that use case, go read it, and you will have good inputs. Yes?
What tool doesn't this completely replace? Like, of all the old classic troubleshooting tools you showed, is there anything that doesn't completely supplant?
I think it really depends. So, for some things, it replaces them completely. But for other things, it's not going to replace any of them completely. Say, with top, right, was extremely limited, as I said. But with top, I can add a column to my process, which is the CPU, I don't know, is maybe the steal time of my CPU, which is a metric that comes from the hypervisor. We haven't integrated that with sysdig yet. Or, I don't know, with the netstat, I can see the routing table. With sysdig, I cannot see it. So, that's why we put sysdig with the ecosystem rather than a replacement for the ecosystem. Because You just really need to know what's available and make the best use of every tool. I think the Unix community, the Linux community, is extremely smart. So things are not going to be replaced. Things are always useful for forever. I mean, there's always a use case that this tool solves that others don't. So I think sysdig will happily coexist with all the others. We'll be more oriented for containers and for this use case, like I said, as a grab for your entire system.
Can you put your slides online? Particularly, I'm interested in that one that showed all the disposable system commands you're talking about. Like
Yeah,
and
that one is not mine. I call essentially I said it's a slide from Brendan Gregg. So if you go on his website, if you just Google Brendan Gregg Linux monitoring tools, I think if you go on Google Images and Google for Brendan Gregg, the first thing that will come up, and there's a much higher resolution that you can keep as a reference. And he also regularly updates it, like every 6 months or so. Yeah. No. Oh, yeah.
So this can really drill down and get a lot of data pretty quickly.
Yeah.
What about HIPAA compliance?
What about, sorry?
HIPAA?
Yeah.
Well, he was asking you, what about
HIPAA compliance. Because you
what's
can,
your question?
I mean, really, you could pull out lots of data. You'd be able to get
Yeah.
like PII and
No,
database.
it's not HIPAA compliant.
Yeah.
The answer is that, yeah, we are a little startup. We like to play with technology. So at the moment, we are having fun with it. And so about regulation and stuff, we still don't have a clear answer. Essentially, our compliance to those things will be explored as a market opportunity presents itself. But you can consider this a tool for geeks by geeks.
The compliance stuff would be up to the creator of the application,
Yeah,
right? However you host your stuff, you're going to say this cluster is HIPAA compliant and the other ones are not. And this one, rolling it out mobs that can do those things.
Yeah.
5 minutes.
All right. Yeah.
So does the cloud infrastructure of the cloud service, does it offer event exports, like if you're into say modules or clusters to get data from there?
The sysdig cloud? Yeah, it offers a full REST API. So essentially, the whole product is data-driven. So it's documented, or if you see something that's cool, it's clear enough that you can right-click, Chrome, Explorer tools, intercept the call, and do it yourself. Yeah.
Is there CLI for the cloud?
No. But there's the API, so yeah, nothing prevents you from writing a use case. Another one.
You said the kernel module is totally open source?
Oh yeah, absolutely open source. Yeah, if you go GitHub sysdig, the kernel module and the sysdig user space are all open source. Just sysdig cloud is complete.
Protect the rest of the kernel, everything else running in the kernel space, if your module has it.
Can you say that again?
How do you protect? How is the rest of the kernel protected if your module has it?
Oh, so the answer is the kernel is not protected. In fact, that's the reason why we try to keep it as simple as possible. At the beginning, I'll admit there were embarrassing bugs. There have been a few kernel panics, and that's very, very bad. Like, of course, we take them very seriously. At the moment, I think it's been like at least 1 year since we have got a serious kernel panic. So again, we use this philosophy where, so essentially, different tools that got the kernel level use different approach. We use the approach that we keep the kernel module simple and we export everything to the user. Other tools like SystemTap or ABPF, let's do everything in kernel, but you write me the script and I will wrap it, into a virtual machine so that no bad code can be executed. Which one is best? It really depends on what you have to do. Yes.
Sorry. You said it was mainly passive until you start asking for things. Like if you just have the kernel module loaded, is it?
Oh yeah. Doesn't do anything. No. It's not in line or anything. We have a hook that essentially, when sysdig, when we run the sysdig user space application in live mode, we'll open a device file /dev/sysdig, and that will trigger a kernel code that will enable a bit that says capture is enabled. And until then, the hooks are not even registered in the driver, so you have zero overhead. There's no overhead in having the driver and not having sysdig running.
Okay, so what about the cloud agent? Because that is sending to the cloud, sysdig cloud constantly, right?
Yeah.
Okay, so that would have a little bit of overhead.
Yeah. In that case, the driver is active 24/7.
I see.
But
So would you recommend in prod?
Oh yeah. We have tons of users and paying customers. We have an established product.
But the overhead is manageable even in prod.
Oh yeah. And then again, I'm not a salesman, so I don't sell anything. I'm an engineer, and what I say is, try it, and if you see that it doesn't work, then don't just ignore, but get back and provide feedback. And I mean, it's in our interest to make it work properly. Oh yeah. So dtrace is part of the spectrum of the tools that I was saying before, that they allow you to write your own script that they get then executed in kernel mode. So you can imagine dtrace as being something that can do all these things if you know how to use it. Sysdig is something that can do like this, a much more limited thing, because with dtrace you can put a hook in every part of the kernel and get your own function in every part of the kernel. It will be almost as powerful as being a kernel developer. It's essentially an alternative to recompile your kernel and adding whatever flavor of troubleshooting you want to do today. But that requires a lot of expertise. And on Linux is not easily available. Sysdig instead, it doesn't allow you to do all that because it captures system calls and export them, so that's the only thing you can do. But it's extremely easy to use, and so again, no tool is better or replacement for the other one. You need to know everything. I mean, if I had a problem where I had the TCP stack behaving weirdly in the kernel and I really couldn't figure out what was wrong, I wouldn't use sysdig. I would use systemtap, which would allow me to write a dtrace script inside the Linux kernel. But that would be a job that would require me 2 days to write the script, and then I would throw it away. And instead, for other things, like seeing just the output of my process, I just use sysdig. You're out, right?
I think we're almost out of time.
Yeah. Okay. Thanks.